look at the 2 points A and B on the coordinate plane below. What is the length of segment AB? Okay, so I've got this line. I cannot count through these diagonals because it doesn't even go perfectly through the diagonals, and you can't count the diagonals anyways. Okay, so whenever they do this to you on a coordinate plane, you are going to make a right triangle. So bring this side straight down and straight over so that we can count the length of these sides and use the Pythagorean Theorem. Okay, so since it's a right triangle, I can use a squared plus b squared equals c squared. Okay, this time I can't like look at it and see what the lengths of these legs are, but it's on a graph so I can count them. So I'm going to count 1, 2, 3, 4, 5, 6 over here. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then I have to label like my A and B and C. So I'm going to put A, B, and remember how you point across from the right angle to label that longest side C, the hypotenuse. So now I can fill in for A, I have a 6 squared plus B is 8 squared equals, I'm trying to find the C. These are both on the same side with a plus, so I'm allowed to type all that work in. 6 squared plus 8 squared equals 100. Ooh. Equals C squared. Okay, so what this stands for, if there was a big old square out here attached to this side, the area of it is 100 units squared, but I don't want its area because they just said what is the length of this segment, so I just need the side of that square. So some number times itself equals 100. To take the squared off, I have to do the square root. So the square root of 100 is 10. Okay, and they wanted the length of it, and I don't know the size of these, so I had to say 10 units. And then you go back to see if that's an okay answer. So I'm going to put my 10 over here. So if I'm solving for C, that always has to be longer than my leg lengths. So 10 is bigger than 8, and 10 is bigger than 6. So yes, I can get 10 for that length of segment AB. Okay, next it says, look at the diagram below. A triangle and 3 squares make up the composite figure. If the shaded triangle is a right triangle, what is the area of square 2? Show your work. Okay, trying to find the area of square 2. So they said 30 units squared and 64 units squared. Okay, so whenever they say units squared, they are giving me the area, okay? The Pythagorean Theorem is all about the area of these squares, okay? So I need to label on here A, B, and a cross on the right angle is always C. So anytime that they give you the area, you do not have to do the squared part of the formula. They've already got the area of this square, okay? So for A, I am only going to fill in 30. Don't bring down the squared, okay? If 30 was just this side length right here, then I bring down the squared part, okay? So I do not have this one, but I do have the area of this side attached to C. It says 64, okay? So I'm trying to get the area of the square. So I want B squared, okay? Right now, on this side of the equation over here, if I cover up equals and all that, there is a positive 30, and I don't want it here. So to make it go away, I need to minus 30 from both sides. So I can cancel it, and B squared is 34. Okay, now I know a lot of you right here, because this is what we've been doing. Whenever you see this, we do the square root. But they did not ask me to get a side length right here. They didn't want this side length on the triangle. They wanted the area of this whole square. So whenever I took this area minus this area, that's all they wanted. Okay, so it is 34 units squared. Okay, so remember that at the very beginning of the Pythagorean Theorem, we said the area of this square and the area of this square that were beside the legs, we add them, and it is equal to that biggest area. So we can check to see if this makes sense. 30 plus 34 is equal to 64. Okay, so that's all they wanted. The perimeters of two squares used to form a right triangle are given in a sketch. Which is the perimeter of the third square? Oh, tricky, tricky. Okay, so they gave us the perimeter. Perimeter comes from adding the outside. And on a square, I know these are 4 equal lengths. So if I want to get the side length, I've got to divide that by 4, and I've got to divide that by 4. So 48 divided by 4 gives me that this side length right here is 12 units. 60 divided by 4 gives me that this longest side is 15 units. So before I can get this one's perimeter, I just need to know how much this side is, okay? So right here I see that I've got 2 sides of a right triangle. Therefore, I will use the Pythagorean Theorem. A squared plus B squared equals C squared to find the length of this missing side. And then with that information, I can get the perimeter of the square. Okay, so before I can use my formula, I've got to label A and B are the ones that make the right angle, and then always across from it, that's the C, the longest side, the hypotenuse. So I'm ready to fill in numbers. A is 12, keep the squared, because that's just the length, plus, I don't know B, that's what I'm trying to find. Beside my C, it said 15, keep the squared, because that was not the area, it was just a length. Okay, so whenever I do the squared part, I'll get the area. 12 times itself is 144. 15 times itself is 225. Okay, so that worked the squared part. The squared part's gone whenever you multiply a number by itself. Okay, I want to solve this for B. It's attached to the squared, so leave that alone. There's a positive 144, and I don't want it here. So minus 144 from both sides. Anytime that you're finding a missing leg, you're going to subtract. If you're ever finding a hypotenuse, you will be adding. Okay, So b squared equals 81. I need the side length, okay? The area of this square down here is 81, but I need the side length so I can get its perimeter. So I'm going to take the square root of both sides. So b is 9. Okay, so somehow I'm going to write that on this tiny, tiny sketch. Okay, I'm going to put it right there. Okay, we've done a lot already on this problem, but it's not done. They wanted the perimeter, so if it's a square, there's 9 on that side, there's 9 on that side, there's 9 on that side, and there's 9 on that side. So the perimeter, I've got to add all sides, or I can do 9 times 4 because there are 4 of them. So the perimeter, 9 times 4 is 36 units. I forgot to do that special step where I made sure that 9 was even okay. Since I was solving for a missing leg, I needed to check to see, is this answer shorter than the hypotenuse number? My longest side was 15, so yes, 9 does work. So I got the perimeter, 9 was on every side. The perimeter of that square is 36 units.